Hello, Calc students, and welcome to another online lesson. Today we're going to be talking about um, probability distributions, going further than we went last class, specifically talking about something called the expectation of a probability distribution. Also, we'll be talking about combination notation, which is some old school math, but many of us may not have actually seen it before or it was a long time ago. So, to begin with, let's start with the combination. Combination notation. Um, this is read n choose r. N choose r is a way of notating the numbers of combination. C stands for combinations. N is the number of terms. R is the number of terms being chosen. It is read n choose r. Other ways of notating this is as follows. Um, Again, still read n choose r, but we have n over the r here in parentheses. We could have the C with n comma r like we have here, n choose r written sideways, n choose r written as subscript. They all mean the same thing. This is a good one because it doesn't even have the C and it's used a lot, but it doesn't have the C, so you need to remind yourself that that means n choose r, and it doesn't look any different than, say, a matrix or a vector. The r can be replaced with other letters such as k. On the calculator, we can do this using math. And under the math option, we have a probability column, and then we can choose n, choose r. But you need to type the n before you do the NCR. So you would be typing like 5, and then NCR 2, and that would be 5, choose 2. And you could hit enter on the calculator to give you that. Now, what does any of this mean? The idea is, let's say I have 4 letters, A, B, C, and D, and I wanted to do 4 choose 1. Well, how many ways are there for me to choose one letter? Well, I could choose just the A, just the B, just the C, or just the D. So 4 choose 1 is 4. How many ways are there for me to choose 0 letters, for example? Well, I would choose none of them, and that can only happen by choosing none of them, so there's one way. How many ways would there be for me to choose all 4 of them? 4 letters, choose 4 of them. Well, I could take the A, B, C, and the D, which would be taking all of them. There's only one way to do that. It gets more interesting when we do things like 4 choose 2 or 4 choose 3. 4 choose 2, I would be selecting 2 of them. I could do the A and the B and the C and the D, the A and the D, the A and the C, so on and so forth. And so that's the idea of what combination is all about. So let's try it out. And get your calculators handy. You first may want to try these without your calculator. 4 choose 0, we just looked at that one actually. Again, how many ways can you choose none of them? There's only one way to choose none of them. 5 choose 3, I could do this without calculator, but I don't know that I want to. So we're going to practice doing that on the calculator. Oops. So, as I mentioned, we can confirm our previous work like we could do 4 choose 0. So I do the 4, then I press math, then I scroll all the way over to probability, and then we have NCR as our third option. So 4 choose 0, we know that answer is going to be 1, and that's confirmed. Now, if I go to the second one, I have 5 choose 3, and so again, I go to the math button, I go to the probability, I just arrowed to the left that time to save myself some arrowing, and then 5 choose 3 gives me 10. So there's 10 ways to choose 3 of 5 things. Number 3, 10 choose 3. This is going to be bigger. So 10 choose 3, 120. And last but not least, 14 choose 14. We don't need a calculator for that. If there's 14 things and you want to select all of them, there is only one way to do that. And you can confirm that if you'd like on the machine. So that is combination notation, which we'll be needing later in this unit, as well as HL Mathematics for any who go on to that course next year. The second part of our learning intention was to talk about expectation. You can have expectation and expectation of a random variable. Expectation is you're basically what are you expecting to get? It's really what you think that means based on our own understanding of the English language. If there are n members in a sample space, so let's say we have 20 things, and the probability of event occurring is p for each member, then the expectation of the occurrence of that event is the number of things times the probability of that event. So we'll look at an example of that in a moment, and that will hopefully clear up just a bit. Expectation of a variable, also known as the mean of that random variable or the mean of that distribution, is the same thing as the expectation of that distribution. E stands for expectation. Again, our big variable x is our probability or our distribution, or random variable. And then how do we find this mean of our distribution or our expectation of our distribution? Well, we have our big sigma here. We have an x, a little x. Little x stands for data. So we're going to take each piece of data. We're going to multiply it by the probability of getting that data and add all those up. And we'll look at an example of that as well. So again, probability, big X equals little x. We looked at that last class. That's the probability of an event X occurring, or an answer or a piece of data X occurring. X is our random variable. It's our labeling our words. And X, again, is just the actual outcome, the numeric outcome. Expectation of a random variable, expected outcome, is often referred to as the mean of the random variable. And I mentioned that all the way back here. So this is a case of where it's more complicated in the formulas than it is to actually do it. So for this problem, a die is rolled 120 times. How many times is a 5 expected to be rolled? Well, the first thing we need is to know n, and we're going to multiply that times p, the probability of our event. Well, n in this case is clearly 120. The probability of getting a 5, well, it's a die, 6-sided die, so how many sides are labeled 5? We would have one of those 6 sides. So we're just doing 1/6 times 120, and that gives us, I believe, 20, yes? Yes. Okay. So our expectation is 20. That's what we would expect. How many times do we expect to get a 5 if we roll the dice 120 times? And that's it. Exciting, I know. All right, now basically the same problem again. This time they've given us the probability, so it's even a little bit easier. We have probability times n, or n times probability. Doesn't matter the order, it's commutative. So we say we have a probability, a 3/4 chance of being successful for a football kicker, soccer player. If in a particular game he has 12 kicks for a goal, how many goals would you expect him to kick? Well, he makes it 3 out of 4 times. We're doing 12 times, so we multiply and we are left with 9. Our expectation is 9. 9 goals. All right, now this one's a little more interesting. This time we have a full probability distribution. How do I know it's a probability distribution? They've listed all of the different outcomes as well as, well, the payouts, and we can figure out the probabilities of those. So in a game of chance, the player spins a square spinner labeled 1, 2, and 3. So we have spinner 1, 2, 3, and 4, and then we have, you know, the spinner that goes around and points at these things. We win the amount of money shown on the table alongside. So we could win any of these values, 1, 2, 5, and 8, depending which number comes up. Determine the expected return for one spin of the spinner. So we have basically 4 different outcomes. We can get $1, $2, $5, or $8. I don't really care about the numbers. I care about the money. We would like to know the probabilities. So I could actually add on to this table here. And I could literally let this just be my x. And then this next row, what do you think I'm going to call that based on last class's lesson? Probability, probability big X equals little x. So the probability of getting that certain amount of winning, um, or the probability that my winnings is $1, for example, well, that would be 1/4. The probability that my winnings is $2, 1/4, 1/4, so on and so forth. Why are they all 1/4? Because we have a square spinner. So it's equally likely for each one of those things to happen. Again, my probabilities all add up to 1, probability distribution. So what's the expected return for one spin of the spinner? Well, this is where we're going to use that sigma, where we take sigma, my data, times the probability. Oops, I did that wrong. The probability of getting that data. So my first piece of data was $1, and I happen to have that 1/4 of the time. So 1/4 times 1 plus, that's what the sigma tells me to do, 1/4 times 2 plus 1/4 times 5 plus 1/4 times 8. So I'm going to multiply all these together, and I'm not going to reach my calculator, so I'll just do 1/4 plus 2/4 plus 5/4 plus 8/4, which equals 1 plus 2 is 8. I'm sorry, 1 plus 2 plus 5 is 8, plus another 8 gives me 16/4, also known as 4, and that was all in dollars. So my expectation, or my E of X, big X, is equal to $4. So that's what I expect to have happen. Now, I can't actually win $4 on any one of these, but over the long haul, that's my mean of this distribution. That's the expected return that I will get on average. So again, you can be paid out more than that. We could be paid out less than that, but on average, we're hitting the $4 mark, and that's what expectation of a distribution tells us. So part B, determine whether you would recommend a person play this game if it costs $5 to play one game. Well, the obvious answer, if it costs $5 and you're only expected to return $4, would you recommend someone plays it? Well, not if the goal is to win money every time. You're losing $1 every single time you play, but that's how gambling works. So now here's a teacher who's going to like make an argument in favor of gambling. But how much does anything cost? You go to a meal, you eat the meal, you spend money, and what do you have to show for it? Well, you're not starving, but a lot of times you're paying money for ambiance. You're paying money for entertainment. You go to a movie, you pay $12 to watch a 3D show, and then it's over, and what do you have to show for it? Well, that's the same thing here. So compared to other games, you're on average losing $1. If that's a small amount to be losing, that's great, and there's always the chance that it won't be that. So this is sort of a TOK question, I would argue here, that yeah, I mean, if the only goal is to make money, then generally gambling's not the way to do that. If entertainment is what is being looked for, then you have to take a cost ratio into sort of account. But we're certainly not making money on average. All right, we've got some problems dealing with expectation in our book on page 616, and we will see you next time.